Good evening, students. So last class we have started with elimination reactions. So what is elimination reaction? It is also called as beta elimination. So when alkyl halides they undergo beta elimination in the presence of alcoholic KOH to yield alkenes. Okay, so one bromoethane, if you react it with alcoholic KOH, okay, so what you get a alkene, okay, and HBr is the side product which is obtained. So when you can see here bromine atom, okay, so here you can see alpha, beta. So beta is nothing but the second carbon from the halogen atom. Okay, so when you have unsymmetrical alkene, alkyl halides, that time you have to follow the elimination will follow the Setzeff rule. So what is Setzeff rule? So according to Setzeff rule, the hydrogen will be eliminated preferentially from the carbon atom which has a less number of hydrogen atoms, and thus highly substituted alkene will be the major product which is formed. Okay. So whenever you have unsymmetrical alkyl halides, what will happen? It will follow the Setzeff rule. Okay. So it will form a highly substituted alkene. So this we have seen in the last class. So we have to solve some MCQs based on elimination reaction. So elimination of bromine from 2-bromobutane results in the formation of A, equimolar mixture of but1-ene and but2-ene, B, predominantly but2-ene, C, predominantly but1-ene, and D, predominantly but2-ine. So what is the product obtained when you react? That is elimination of bromine from 2-bromobutane. So it will be, so I'll write the structure of 2-bromobutane. So 2-bromobutane, so butane means 4 carbons, so CH3, CH2, CH, CH3. So 1, 2, 3, 4. Okay. So at the second carbon, so what it is a 2-bromobutane. So your bromine is present. Okay. So 2-bromobutane, when it reacts, so what will happen here? 2-bromobutane. Okay, it will undergo a elimination reaction. So this is a alpha carbon, right? This is a alpha carbon. This is beta carbon. This is beta carbon. So what will happen according to Setzeff rule? The elimination will take place from carbon having less number of hydrogen atoms. So it will prefer this. So what will be the product obtained? So it will be CH3, CH, double bond CH, and CH3. So it will undergo a beta elimination. That is, hydrogen and one bromine atom will be removed. That is dehydrohalogenation reaction. Okay, so what is the name of this? 1, 2, 3, 4. Okay, so it is but2-ene. So this is a major product which is obtained. Okay, this is a major product which is obtained. So this is a major product which is obtained. So it is 2-butene. So which is our answer? It is second answer. Okay, it is predominantly but2-ene. So answer is but2-ene. Okay, so we'll go for the next one. N-propyl bromide on treating with alcoholic KOH produces. So what does N-propyl bromide when you are treating it with alcoholic KOH? Okay, what it gives you? So what is N-propyl? N-propyl, what is the structure? N-propyl means 3 carbons. So it will be CH3, CH2, CH2, and Br. Okay, N-propyl means it will be a straight chain. So when it is reacting with alcoholic KOH, what is alcoholic KOH? Alcoholic KOH is a dehydrohalogenating agent. Okay, it is a dehydrohalogenating agent. So what is happening here? So alcoholic, it will undergo a dehydrohalogenation. Okay, it will undergo dehydrohalogenation. So this is N-propyl bromide. What it is? It is N-propyl bromide. So when it is treated with alcoholic KOH, okay, it undergoes dehydrohalogenation. So what is the so alpha and beta? Okay, so it will form CH3, CH double bond CH2. Right. So it will undergo alpha elimination, alpha beta elimination. Okay, so this will be the product which is obtained, and KBr plus water. Okay, so this is the reaction. So what is the name of this? 1, 2, 3. Okay, it is a propene. So option number D, propene. Okay, it is a propene. So option number D is the correct answer. So we'll go for the next one. identify Z in the following series. So you have to identify the Z in the following series. Okay. So C2H5, that is ethyl iodide. Okay. So ethyl iodide, when you are treating it with alcoholic KOH, when you are treating it with alcohol. So when ethyl iodide, when it is treated with alcoholic KOH, okay, you have to tell what is X obtained. Then you have to treat that X with Br2, that is bromine, and then you will obtain the product Y. Then this Y you have to treat it with potassium cyanide, and you have to obtain the product Z. Okay, so this is the series what you have to follow. So I'll write it here. So ethyl iodide. Okay, ethyl iodide, first you have to treat it with alcoholic KOH. So what will happen here? So ethyl iodide, when you treat it with alcoholic KOH, so it will undergo a dehydrohalogenation. So there will be elimination of one hydrogen and the halogen atom. So it will yield CH2 double bond CH2. Okay. So what it will do, it will form a alkene. So this is a ethene. So this is a ethene which is obtained here. Our product X is what? Our product X is. Okay, so ethene. So ethene is a product. Now this further you have to treat it with Br2. So when you are treating it with bromine water, so this bromine water, when you are treating it with ethene, okay, so this will give colorization. Okay, it will colorization, that is it is used for testing the unsaturation, that is presence of double bond or triple bond in the molecule, okay, or a compound. So when bromine water, when it is treated, so across this double bond, the Br atoms are added. So it will become CH2, CH2, Br and Br. Okay, so it is 1,2-dibromo ethane. Okay, 1,2-dibromo ethane is the product which is obtained. So this is a Y. So this is our Y, this is our X. Now this Y, further you have to treat it with KCN, that is potassium cyanide. Okay, you have to treat it with potassium cyanide. So what is happening now here? This Br atoms will be replaced by cyano group. So it will be CH2, CH2, Cn, and Cn. So this is the product which is obtained. So which is our answer? Yes, you have to follow the steps. So this is our Z. Okay, so you have to follow the steps and whatever is written on the arrow. Okay, so just follow and you will get the answer. So when ethyl iodide, when it is treated with alcoholic OH, you get ethene. Okay, that is it undergo a dehydrohalogenation reaction. Further, when you are treating it with Br2, okay, Br2, what it is doing, Br2, it is the test for unsaturation, whether the given molecule, okay, given here, okay, whether it has any double bond or triple bond in it. Okay, so Br bromine. So what is happening? The double bond will be replaced by your Br atom. So each carbon will be attached with bromine atom. Okay, so this test that there will be a saturation present, unsaturation present. So further, this is a Y which is obtained. Further, you have to treat it with potassium cyanide. These Br atoms are easily what you can say leaving group. So what will happen? This will be replaced by your cyano group. So this is the answer what you're getting. So option number B. Okay, option number B. So after seeing this, which is answer, it is option number B. So we'll go for the next one. Okay, so next question, we'll go for the next question. A mixture of 1-chlorobutane and 2-chlorobutane when treated with alcoholic KOH gives, okay. So 1-chlorobutane. So what is the structure of 1-chlorobutane? So butane, you know, it is CH3, CH2, CH2, and CH3. This is butane. Now what I have to do at first position, okay, at one position, I have to add here the uh, chloro group. Okay. So what I'll do, I'll replace one of the hydrogen. That is, I'll do it CH2 and I'll write it Cl. So this will be 1, 2, 3, 4. So this is 1-chlorobutane. Right. This is 1-chlorobutane. Then this you have to treat it with what? This you have to treat it with chlorobutane. So that is CH3, CH2, CH2, and CH3. Okay. So this will be Br will be here. Okay, now here what will happen? So here only one H will be there. Okay, you have to balance the hydrogens. Okay, if carbon will have only tetravalency. So this will be tetravalency. Okay, so this is 2-chlorobutane. So this is 2-chlorobutane. So when you treat this both mixture of 1-chlorobutane and 2-chlorobutane with alcoholic KOH, what will happen with when you treat it with alcoholic KOH? It will undergo a dehydrohalogenation reaction. It will undergo what? Dehydrohalogenation reaction. Okay. So we'll see the. Okay, so here when we are treating 1-chlorobutane and 2-chlorobutane with alcoholic KOH, so what are the steps we have to follow? So here we are treating this mixture, okay, with alcoholic KOH. So here what you'll obtain, so when you treat it with this, first when I treat it with what you can say, first when I treat the 1-chlorobutane with alcoholic KOH. Okay, what is the product which is obtained at first? So it will be CH3, okay, alpha. So this is alpha, this is beta, right? So this is alpha, this is beta. So how the product will be obtained? So alpha beta means here from this here the carbon will, so it will be CH3, sorry, not CH3, just a second. So it will be CH2 double bond CH. So here alpha beta, right? So the double bond will be formed here. So CH2, CH, then CH2 and CH3. So this is 1, 2, 3, 4. So what is the product? It is 1-butene. It is 1-butene. Okay, it is 1-butene. Then this, when you treat it with alcoholic KOH, when you treat it with alcoholic KOH, what you obtain. So again here, this is alpha carbon, this is beta, this is beta. But according to Sedzep rule, the hydrogen will be removed from the the hydrogen will be, the double bond will be formed, okay, between the carbon which has less number of hydrogen atoms. Okay, so highly substituted alkene will be formed. So it will be CH3, CH, double bond CH and CH3. Okay, so this is 1, 2, 3, 4. So it is 2-butene. Okay, so which is a, so after you treat it with alcoholic KOH, okay, when you are treating the mixture with alcoholic KOH, so you will obtain what? So you will obtain two things here. So here you'll obtain 1-butene with the mix one chlorobutane. So when you treat it with 1-chlorobutane, okay, you will obtain 1-butene, and when you are treating with 2-chlorobutane, okay, with alcoholic KOH, you will obtain 2-butene. So which is the answer? Our answer is mixture of 1-butene and 2-butene. Okay, so this is our answer which we have got. Okay, so we'll go for the next question. So the next question is reactivity orders of alkyl halides for dehydrohalogenation is. Okay. So which is the reactivity order of alkyl halides? So when you are when you know that halogens, they are from group 17. Okay, they are from group 17. So these are highly electronegative atoms. So how is the arrangement as you go down the group? Fluorine, bromine, fluorine, bromine and iodine. Okay, so these are the atoms of halogen. Okay, so these are the elements which are present in the halogens. So fluorine, chlorine, bromine. So as you know, what will happen to the atomic size? You know that as you go down the group, the size will go on increasing. The atomic size goes on increasing. Okay, how it goes on increasing? Because as you go down, there will be addition of new subshell. Okay, there will be addition of new subshell. So as you're adding new subshell, okay, so as you go down, so iodine will be having the highest size, fluorine will be the least. Okay, so when you are seeing the reactivity order, so negative charge will be more on larger atom. So when you are seeing the order of reactivity, so negative charge will be more. Okay, it will be more on the larger atoms, and the CI bonds, okay, will break more easily. So when you are comparing the reactivity, so as the negative charge will be high on the larger atom, so this CI bond, okay, will be broken easily than that of the CF bond. So the reactivity order is Ri is greater than Rbr, is greater than RCl, and is greater than Rf. So option number, which is the correct answer? Option number B. Okay, option number B is the right answer. So as you go down the group, so fluorine is the smallest, okay, and iodine is the highest. So as you know, the negative charge will be more on the larger atom. So Ci bond will be broken easily. Okay, the bond will be broken easily than that of the CF bond. So this is our reactivity order. So reactivity of alkyl halide towards dehydrohalogenation. We have explained what is dehydrohalogenation. Dehydro means there will be elimination of one hydrogen and one halogen. Okay, there will be elimination of one hydrogen and one halogen. So this is called as dehydrohalogenation. So the reactivity order of alkyl halides will be this. Okay, so that is Ri will be greater than Rbr, will be greater than RCl, will be greater than Rf. I hope this is clear. Okay, so we'll go for the next one. So next we are going to start with the reaction with metals. Okay, how the alkyl halides, okay, they react with metals. So first is with sodium. So when alkyl halides, when they react with sodium in the presence of dry ether, it yields alkane. It yields what? It yields alkane. Okay, so with sodium, so I'll take two molecules or two molecules of alkyl halides. So Rx, okay, plus 2Na. So I've taken two sodium atoms, okay, element, we are reacting with two sodium plus again Rx. Okay, I've just rearranged and I've written the alkyl halide. So this is also a alkyl halide. Now in the presence of dry ether, so Wood's reaction is what? When two molecules of alkyl halide reacts with sodium in the presence of dry ether, it yields you alkane. So I'll just show you how the elimination takes place just here. So R and R. Okay, so this will get joined and the side product obtained will be 2NaX. So your X can be Cl, bromine, etc. Okay, so what will be the obtained? RR. Okay, that is alkane. So higher alkane is obtained. Okay, a higher alkane is obtained. So Wood's reaction is what? So alkyl halide, two molecules of alkyl halide is treated with sodium. Okay, it is treated with sodium in the presence of dry ether to give you higher alkanes, and sodium halide is the side product which is obtained. So this is the first reaction with a metal, that is sodium metal. Then second is with magnesium. Okay, with magnesium. Next we'll see with magnesium. So when alkyl halide, that is Rx, is treated with Mg. Okay, when Rx is treated with Mg in the presence of ether. Okay, that is, this reaction is called as RMgX. Okay, so this is the organometallic compound. Okay, this is a organometallic compound. Okay, this is called as what? It is called as organometallic compound. Okay, so when alkyl halide is treated with magnesium, so you know that magnesium is a metal. So when you treat alkyl halide with magnesium in the presence of dry ether, okay, your ether is a solvent. Right. So ether, when you are treating it with ether, what it will form? RMgX. Okay, what it is forming? It is forming or RMgX, and this is called as organometallic compound, or it is called as the Grignard reagent. Okay, very important. What is Grignard reagent? Grignard reagent is RMgX. RMgX is your Grignard reagent. Okay, so this is the correct answer. Okay, I hope you have got it. So the two reactions we have seen, one with the that is the sodium metal, and second with the magnesium. So when alkyl halide is treated with magnesium, it forms a organometallic compound, or it is called as the Grignard reagent. So when lithium, so with the lithium, okay, with lithium, so the next reaction is with lithium. The metal taken is lithium. So when Rx, that is alkyl halide, is treated with lithium, it forms alkyl lithium. Okay, it forms a alkyl lithium. So this is the reaction, alkyl lithium plus lithium halide. Okay, plus lithium halide. They have taken two. Okay, the number coefficient is 2 here. So there are two, okay, two atoms of lithium. So R lithium, that is alkyl lithium plus lithium halide is the product which is obtained. So this is our third reaction with the metal. So first we have seen with sodium, second is with magnesium, and the third is with the lithium. Okay, so next is Woods-Fittig reaction. Now, before going to this Woods-Fittig reaction, what is Fittig reaction? Okay, then we'll go for the coupling reaction, that is Wood-Fittig reaction. So what is this Fittig reaction? Not fitting, okay, Fittig reaction, Fittig, Fittig reaction. So Woods reaction was what? I'll just recall. So what is Woods reaction? When alkyl halides, okay, when alkyl halide is treated with sodium, it forms higher alkane plus 2NaX. Okay, so this is a alkyl halide. Okay, this is a alkyl halide is treated with sodium in the presence of dry ether. Now, what is Fittig reaction? Instead of alkyl halide, you are taking aryl halides. What you are taking? You are taking aryl halides. Suppose I have taken, this is a, okay, I'll take a general reaction only. So this is what? Aryl halide. So 2Na plus, so there will be two molecules, right? There will be two molecules of aryl halide. So this is aryl halide, aryl halide. This is also aryl halide. Okay, this is aryl halide. So what will undergo in the presence of dry ether? What it will form just here. So this, okay, these will be added and these two will be joined. Okay, so what will be the product? This will be diphenyl. Okay, so this is the product which is obtained. So here in this reaction, that is Fittig reaction, you are taking the aryl halides. Okay, and in Woods reaction, you are taking the alkyl halides. So diphenyl is formed and 2NaX is formed. Okay, diphenyl is formed and 2NaX is formed. 2NaX is formed. So this is a reaction with what? It is a reaction with your. So this is a reaction with your Fittig reaction. Okay, this is Fittig reaction. Woods reaction is what? Woods reaction is with alkyl halides. Okay, Woods reaction is with alkyl halides and Fittig reaction is with aryl halides. So these are the reactions. Now we'll see the coupling reaction, that is Wood-Fittig reaction. Okay, now what is Wood-Fittig reaction? Now you know in Woods reaction we are taking two alkyl halides. In Fittig reaction, we are taking two aryl halides. Now, in Wood-Fittig reaction, what we are supposed to take? We are going to take one aryl halide, okay, sorry, alkyl halide, and we are going to treat it with sodium. And again, one is a one aryl halide. Okay, so this is the, so this is a reaction, alkyl halide, alkyl halide. This is aryl halide. Okay, so one alkyl and one aryl halide is treated in the presence of dry ether. Okay, in the presence of dry ether. And what is formed here? Just see. So what is formed here? R. Okay, and we'll combine with this. Okay, so what will be the obtained? It will be this. This is the product which is obtained. So it will be R. Aryl, alkyl aryl halide. Alkyl aryl. So alkyl and when aryl, this is obtained. Okay, so this is the product which is obtained. So and this will be 2NaX. This will be the product which is obtained. So this is Woods-Fittig reaction. Okay, this is a Woods-Fittig reaction. You can take R anything, any alkyl halide, methane, ethyl, okay, propyl, benzyl, anything, and this will be one benzene ring. So in Woods-Fittig reaction, one alkyl group and one aryl group, okay, it will be treated with sodium dry ether, okay, and you will obtain the product. Coupling reaction will takes place. So we'll go for the next one. So we'll solve some questions based on this. So CH3MgBr is an organometallic compound. Okay, so CH3MgBr, it is said to be an organometallic compound due to, so why it is called as organometallic compound? A, NgBr bond, then B, CMg bond, then B, CMg bond, C, CBr bond, and D, CH bond. So because of which bond is this organometallic compound is said to be a, why it is said to be a organometallic compound? So here the CH3MgBr. Okay, when we are talking about this organometallic compound, that is methyl magnesium bromide. So this is a methyl magnesium bromide. Okay, it is a methyl magnesium bromide, which is a organometallic compound. So there is a methyl group, so it is called as organo. Then there is a metal. So which metal is involved here? Mg is involved. So metal organometallic compound. So this makes a organometallic compound. Now, why this bond is present? Why this bond, or which bond is present, or which describes the organometallic compound? So this is due to the bond between the carbon and Mg, that is C and Mg bond. Okay, so C and Mg bond, it is due to CMG bond. So that is option number B. So because of this CMG bond, it is said to be an organometallic compound. Because CH3MgBr, it is itself a organic compound due to presence of the metal and carbon bond. Okay, it is due to the carbon and metal bond which is associated. So we'll go for the next one. Grignard reagent is not prepared in aqueous medium, but prepared in ether medium because. Why this Grignard reagent? It is not prepared in aqueous medium, but it is prepared in ether medium. A, it is insoluble in water. B, the reagent is highly reactive in ether. C, the reagent reacts with water. And D, the reagent becomes inactive in water. So why it is not prepared in aqueous medium, but it is prepared in ether? Because the reaction, okay, when you see the RMgBr, that is RMgBr, so this is a Grignard reagent. If you treat it with water, so what it will form, the reaction is it forms a alkane and MgBr OH is formed. So it forms a alkane. So when RMgBr is treated with water, okay, it forms a alkane. So because of this, it is not treated with aqueous medium, but it is treated with ether. Okay, it is treated with mether because the reagent reacts with water. What is it? The reagent will react with water because the Grignard reagent will react with water. So if we prepare with water, it will form alkane. But what we want Grignard reagent. So this Grignard reagent will be prepared in ether itself. It will be prepared in ether itself. So the reagent, so why it is not prepared in aqueous medium, but it is prepared in ether medium because the reagent reacts with the water. Okay, I hope you have got it. So we'll go for the next question. When 1-chlorobutane and 2-chloropropane are treated with metallic sodium in ether, we get. Okay, so what we get when 1-chlorobutane and 2-chloropropane are treated with metallic sodium in ether. So I'll write the structure. What is butane? Okay, CH3, CH2, CH2, CH2. So this is butane, and at one position, so this is 1, 2, 3, 4. So at first position, you have a, so this is 1-chlorobutane. This is 1-chlorobutane. This will be treated with sodium. Okay, 2Na and 2-chloropropane. So I'll take 2-chloropropane now. The structure of 2-chloropropane. So propane is CH3, CH and CH3. This will be 1, 2, and 3. Okay, so 1-chlorobutane and this is 2-chloropropane. Okay, so this is 2-chloropropane. So 1-chloropropane and 2-chloropropane, when it's reacted in the presence of dry ether. Okay, when it is present in the reacted with the presence of dry ether, what it will obtain? Just see how the elimination will take place. I will just show you. So Na, this will be removed. Okay, this will be the side product. It is 2NaX. Okay, now what will happen? This H will be joined here. So I'll write the structure. So CH3, CH2, CH2, CH2. Then this will be CH. This is CH3 and CH3. I hope you have got it. So what is the name? It is 1, 1, 2, 3, 4, 5, 6. So it is 2-methyl. Okay, 2-methyl and hexane. Right, 2-methyl hexane. So is the answer present in our options? Yes. So it is option number A. Okay, it is option number A. So this is a very easy. Okay, they have given the name of the compounds. Just we have to write the structures. So when so 1-chlorobutane and 2-chlorobutane, we know the side product obtained is sodium halide. So this will be the type of elimination it will undergo. So this side will be joined with this side. Okay, so it is 2-methyl hexane is the product which is obtained. I hope it is clear. Yes. Okay, so this is the reaction. Okay, that is a Wood's reaction. Okay, Wood's reaction wherein you are reacting the alkenes, alkyl halide. So alkyl halide is treated with sodium in the presence of dry ether. It will give you a higher alkenes, right? So this is the how you have to solve this particular questions. So we'll go for the next one. Cycloalkane formed when 1,4-dibromobutane, a pentane, is heated with sodium is. So they have given cycloalkane. So cycloalkane. Okay. So which is a cycloalkane form they are asking. So I'll write the structure of 1,4-dibromopentane. So 1,4. So pentane will be so dibromo. So 1, then 2, then 3, 4. Okay. And this is so this is 1, 2, 3, 4, 5, and 6. So this is 1,4-dibromopentane. Okay, so it is 1,4-dibromopentane. When it is treated with 2 sodium, okay, when it is treated with 2 sodium, what it will obtain, what it will be forming. Okay, so this is the side product which is obtained, right? So it will be 2 NABR, and the product. So this and this will get joined. Okay, this and this will get joined. So this and this will get joined, and you will get CH2, CH2, CH2. This is CH2, and this is CH3. Okay, so it is methyl cyclobutane. So answer is methyl cyclobutane. So option number A is the answer. I hope you have got it. So they have asked which is the cycloalkane obtained. So which is the cycloalkane obtained when 1,4-dibromopentane is heated with sodium. Okay, so we have written the structure of 1,4-dibromopentane. So here there will be elimination of alkyl sodium halide. Okay, then this 2 CH2 will join and it will form a cycloalkane. Okay, I hope this is clear. Yes. So we'll go for the next one. When neopentyl bromide, okay, so when neopentyl bromide is subjected to Wood's reaction, the product obtained will be. So I'll write the structure of neopentyl bromide. So how is the structure of neopentyl bromide? Neo means carbon atom, pentyl, so CH3. Okay, so this will be CH3, this will be CH3. So 1, 2, 3, 4. So this will be 5. So, and there is a bromide. So one of the hydrogen will be replaced by Br. So when neopentyl bromide is subjected to sodium. So sodium. So again for this we require 1 mole molecule of pentyl bromide. So I'll write the structure here Br, CH2, C, CH3, CH3 and CH3. Okay, so this in the presence of dry ether. So this you have to treat it with dry ether. What you will obtain, just see. This is the side product which is obtained. So it will be 2NABR. Okay, this is 2NABR which is obtained. Then how we will join this? This will be CH3, C, CH3, CH3, CH2, CH2, C, CH3, CH3 and CH3. Okay, so this is the plus 2NABR. Like this. Okay, so this is the product. Now we'll write the name 1, 2, 3, 4, 5, and 6. So it is 2, 2, 5, 5, tetra. Tetra, why tetra? Because there are 4 atoms. 1, 2, 3, 4. So 4 tetra methyl. Okay, methyl. Then it is hexane. It is hexane. So it is 2255 tetramethyl hexane. So our answer is option number C. Okay. I hope you have got it. So whenever you have alkyl halides, it is reacting with sodium in the presence of dry ether, it is a Woods reaction. Whenever you have aryl halides, okay, two molecules or two compounds of aryl group, it is treated with aryl halide treated with sodium in the presence of dry ether. It will give you Wittig reaction, and one aryl halide and one alkyl halide will give you Wood-Fittig reaction. Okay, I hope you have got it. Yes. Okay, so we have come to the end of elimination reaction. Okay, so this substitution reactions about substitution reactions. So we shall start this as a new topic in the next class. Okay, I hope today's session is clear. So substitution reactions. So here we are going to see the nucleophilic substitution reactions. Okay, to this we are going to see SN1, SN2. Based on that, we are going to see some MCQs. Okay, so this will continue in the next class. I hope everything is clear. Yes, so I shall end the session here and we can meet in the next class. Thank you. Have a good day.